Hello, good evening, everyone. We will wait for 2 to 3 minutes for the participants to join and then we will start.
Okay, ma'am.
Okay, I think we can start. So, good evening. Welcome to the third problem solving session for the course Municipal Solid Waste Management. I am one of the TA for this course. My name is Asma Parvi and I am a PhD scholar at IIT Kanpur. So, in this course, we have completed 3 weeks. In the first week, it was about introduction about solid waste. What are its classification? What is municipal solid waste? What are its characterization? What is the physical characterization, chemical and biological characterization. And then second week was about a collection system, that was the primary collection and secondary collection. So primary collection is known as collection services and secondary is known as collection system. So in secondary collection system, we have seen two types of system, hall container system and the stationary container system. And the third week is about transfer stations and numerical based on secondary collection systems, that is the hall collection system and the stationary collection system. So what we will do is like previous weeks we will go through a quick recap about what was taught in the week 3 module, and then we will try to solve few numericals based on that and some of the objective the questions also. So first let me share my screen. So before that, if any one of you have any doubt, then I'll be more than happy to discuss that. So any one of you have, if any one of you have any doubt, just unmute yourself. You can say your doubt or you can write in the chat box. Okay. Okay, if there is no doubts, then we can move to the content part.
Ma'am, sorry, I was on mute. I had posted one Q&A. So it was
Yes.
about, so there are some compostable bin bags available in the market.
Okay.
Are they really biodegradable? Are they good alternative to plastic? That is what I wanted to understand.
Compostable bins or
Yeah,
bags.
bin bags for the household. So we have bins where we put those plastic bags, and then we put our wet waste, dry waste there. So those small bags, I mean. So
Uh,
earlier, the means we in our area we used to get, or even we get the black colored polyethylene bags. But now in the market, like in Dmart, they sell some green colored bags, and they call it biocompostable plastic, which can be which is biodegradable. That is what they have written on the label, and they are quite expensive bags, like around 5 rupees to 6 rupees per bag they charge. So for 10 pieces it is roughly around 70-75 rupees. So I just wanted to understand, are there really a good substitute for plastic, or that really doesn't, they are not, are they not environmental friendly?
So the black bags, plastic bags you are talking about, so these are the single-use plastic, and it is very good to shift from the single-use to recyclable plastics or to the compostable ones. So if they are selling the bags which are biodegradable, then definitely it is a better option than the single-use plastics. Now this is better option as compared to the single-use plastics. So that's why the black polythene bags, which we used to get in the shops or in the vegetable vendors, so that has been replaced by different plastic bags or by jute or paper bags.
Okay, ma'am. Yeah, thank you.
Okay. Okay. Thank you. So I think my screen is visible. So lecture 11 was about analysis of collection system. So we will see what are the. So, why analysis of a collection system is important? Because all the resources allocation, like labor, what will be the capacity of vehicle, how much time will be required to cover a particular area. So, all these can be analyzed through the collection system analysis. So, there are four major operations which takes place during the collection system. First is the pickup, next haul, at site, and off route. So here a whole container system with conventional mode of operation is shown, where the vehicle at the beginning of the day goes to site one, it empties the container there and goes to the transfer station or some other material recovery facility and return back to the previous location, keeps the empty container and again drive to the second location, do the same operation. That is, it takes the bin to the transfer station, return back to that location, keeps the container, and so on. So this is for the conventional mode operation. Again, here it is a haul container system for the exchange container mode, where the vehicles start at the beginning of the day start with an empty container. So there is an empty container already in the collection vehicle. It goes to location one, keeps the empty container there, and takes the full container and goes to the transfer station. And instead of going to location one, it will go to location two. Now here it will have already a emptied container, so it will keep the container there and take the full container, goes to transfer station, and then it will go to location number 3. So as compared to the conventional mode, here in the exchange container mode, we can see that the time between traveling from location 1 to 2 and also from going back to the going back from transfer station to location 1 is omitted, and that's why here time will be utilized in a better way. So the four components were pickup, haul, on-site and off-site. So the pickup time, it includes the time spent in picking up the loaded container. So here how much time will be spent in picking up the loaded container. Then after picking up and after emptying the and after going to the transfer station, it will return back to location 1 and it will keep the empty container there. So the time spent in keeping the empty container at that location, it will included in pickup time. And the next is the driving to the next location. So the time spent between driving from location 1 to location 2 will be the DBC. So pickup time is the summation of PC, UC and DBC. Next is the haul. So haul is the time required to reach the location where the waste will be emptied, starting where the container has been loaded on the truck and continuing through unloading until the trucks arrive at the location where the empty container is to deposit it. So here the time spent from location 1 to the transfer station after loading of the container, and the time spent from transfer station to the location 1 after the unloading has been done. So the time spent at the transfer station is not included in the haul time. Only the time required to go from the location to the transfer station and from returning from the transfer station to the location will be included in the haul. Next is the at site. So this is the time spent at the transfer station or the landfill or the material recovery facility where the unloading of the trucks will be done. So it will also include the time spent during the loading and unloading and also during the waiting time. So all these times will be included at the at site. Next will be off route. So generally around 15% of the total time of the entire day is taken as off route in the non-productive activities like traffic or during the tea breaks or during the waiting time at the landfills or the transfer stations. So all these are accumulated in the off route. So here we will see these are few of the formulas which are used to design the haul container system. So the total time per trip will be summation of the pickup time, at site time and haul time. And we will see all these while solving the numerical also. So we will see a similar numerical while solving the questions. Now let's move to the second lecture, that is the lecture 12. It was about analysis of collection system based on stationary container mode. So like haul container collection system, in stationary collection system we have 4 operation units, that is pickup, haul, at site and off route. So in stationary collection system, what happens? The truck starts its daily routine by going to location 1. Here they empty the containers at location 1 and they keep the emptied container there, and the truck with the garbage goes to location 2. It empties the containers into the truck there and it will goes to end location until the end of the day, and after either at the end of the day or either by till the truck or container is filled, it will go to different locations, collect the waste, and it will finally go to a transfer station or material recovery facility or something like that, like a disposal site, and it will and if some time is left, then it will go to serve some other area or location. So here the pickup time, it refers to the time spent in loading the vehicle and beginning with the stop to load the first container and ending when the last container has been loaded. So this is about uh, all the locations will be served. So the time spent to load the vehicle, and suppose if that particular truck is serving 3 locations, then it will include all time spent in loading the vehicle from all the 3 locations, and also the time spent between driving from first location to second and second to third. Next is the haul time. It is the time required to reach the location where the full vehicle will be emptied and continuing until the truck arrives at the location where the first container will be emptied for the next route. So here suppose the container has served n number of routes and now the truck is full. So the time spent from going from the nth location to the transfer station, and again if there is some time left, then the time spent in going from the transfer station to the second locality, it will be the overall haul time. Next is the at site time. So it is the time spent at the site in loading, unloading, and all these. And next is the off route time. So off route is similar to the for stationary collection system is similar to the hall collection system. Generally, 15% of the time is taken as off route. So here these formula we will see in the questions. So the formulas are slightly different based on the collection system. So let's move to the next lecture. So lecture 13 was about comparison between the secondary collection system and collection system. So here a numerical was discussed. Let's go to the final solution. So here a numerical was discussed in which the container system and stationary container system was to compare for a locality. So here from final solution we got to know that hall collection container system are cheaper for lesser haul distance as compared to the stationary container system. So here in the stationary container system we can see that the variation in the overall collection cost is very less, but in the haul container system we can see that as the haul distance is increasing, the cost per week is increasing almost linearly. So for shorter haul distances, haul container system are better as compared to the stationary container system. But for longer haul distance, stationary container system will be much cost effective as compared to the haul container system. So let's move to the last lecture. So the last lecture is about transfer and transport. So we have discussed about waste generation, waste handling and storage. In the collection we have discussed about primary and secondary collection. Now this lecture is about transfer and transport. So this is basically about transfer, that is the transfer station. So these are few of the, so a transfer station is a processing site where waste is deposited temporarily. So in transfer station, waste collected from the different areas of the city can be dumped for temporary purpose, and from the transfer station, the waste can be taken to the landfill or to the processing units from where the waste will be recycled and processed. So these are this is a picture for the transfer station in US. Next, we will see what are the need for transfer operations. So transfer station operations are needed to haul distance to available processing site or disposal sites are high. So transfer station will be required if the distance to travel from the processing site or disposal site is very large from the location to be served. Next, the processing center or disposal sites are in remote location and cannot be reached directly from highways. So if the haul distance is very large, so we will need to have a transfer station. It will reduce the collection cost by greatly. And also, if the processing or disposal sites are at some places where it cannot be accessed by road, so we can have transfer station, and then from the transfer station by some mode we can transfer the waste to that landfill or the disposal site. Next, what are the factors which influence the influence the need for transfer station is first is the use of small capacity collection vehicle. So if small capacity collection vehicles are used, so after serving the particular location, it will get filled, and from these smaller vehicles, the waste can be taken to a transfer station. There it can be emptied, and again the vehicle can go and serve the other locations. Next is the use of hall container system with relatively small containers for the collection of waste from commercial sources. So these are the hall are the vehicles in which the containers, dustbins, or the collection bins are loaded and taken to the transfer station. There it is emptied, and again it can go to serve different locations. Next is use of hydraulic or pneumatic collector systems. So these are the trucks in which which bins are loaded mechanically, and these bins can be emptied in the transfer station. Next, the transfer station, if if a recycling facility is also incorporated in the transfer station, then it will be very cost effective, and also lot of recyclables can be sorted and sent for different processing. So these were the needs for the transfer station. So week third was about numericals based on the collection system, and about transfer stations. And next, further lectures, I think it is about processing of the waste, like by composting, incineration, and all. So let's go to the question part. First, let me share my screen for that. So the first question is, what are the unit operations of hall container? So the first question is, what are the unit operations of hall container system? So here more than one option can be correct. A, pickup; B, haul; C, add site; or D, off route. So this is a direct question from the lecture. I hope everyone of one of you will be able to write the correct options. So please write the options in the chat box, and then we will see which is the correct option. So the correct answer is all four. So the unit operation of the hall container system as well as stationary container system are pickup, haul, at site, and off route. So I'll request all of you, every one of you, to please participate in these questions. It will help to solve the assignment question as well as to solve the question during the written exam. So let's move to the second question. So in the second question, a figure is given. We have to identify which collection system is represented by given below, by given figure. A stationary collection system, B hall container system with the conventional mode of container exchange, or C hall container system with exchange container mode, or D none of the above. So we have to find out of the stationary or hall container system which system is represented by this figure. So I'll give you all 3 minutes. Please write the whatever option you think is correct. Please write that in the chat box, and then we will discuss which is the correct option. So I got 2B, 1, 2, 3B, and 1C. So C is not the correct answer. B is the correct answer. The figure shows hall container system with the conventional board. Here the vehicle starts by going to location 1. It takes the full container to the transfer station or some other disposal site or some other treatment facility, or and then brings the empty container to its original location and then drives to the next location. So it is the hall container system with conventional mode of operation. So B is the correct answer. So let's move to the next question. So the third question is, what does pickup in hall container system refers to? So here also more than one option can be correct. So A is picking up the loaded container. B is redeposition of the container after it has been emptied. C, driving to the next container after an empty container has been deposited. And D, the time required to reach the location where the waste will be emptied, starting when the container has been loaded on the truck and continuing through unloading until the truck arrives at the location where the empty container is to be redeposited. So we have to describe what does pickup and haul container system refers to. So again, I will give you 3 minutes. Just take your time, read the options, and write the option which you think is correct in the chat box. So I got only one correct answer. So A, B, C, all the three of so A, B, and C are the correct option. D, that is the time required to reach the location where the waste will be emptied, starting when the container has been loaded on the truck and continuing through unloading until the truck arrives at the location where the empty container is to be redeposited. So this is the haul time. And A, that is the picking up the loaded container. B, redeposition of the container after it has been emptied. And C, driving to the next container after an empty container has been redeposited. The sum of all these three time is the overall pickup time. So A, B, and C, all three are the correct. These three are the correct answer. So A, B, and C are the correct option. So let's move to the next question. So question 4 is how much of route is taken in HCS, that is the hall container system, and SCS, that is the stationary container system. So off route is the overall time which is spent in other activities like tea break or traffic or other and others. So four options are given: A 10%, B 15%, C 20%, or D 25%. So out of the total time of the entire day, some percentage is taken as off route. So we have to find out which is the how much percentage is taken. So again, I will give you 2 minutes. Just take your time and write the correct option in the chat box. So B is the correct answer, that is 15%. So out of the overall time of the day, 15% is taken as off route. So B is the correct answer. So let's move to the next question. So the question is, what are the types of transfer station? A, direct load, B, storage load, C, combined direct load and discharge load, or D, all of the above. So there are different types of transfer station, and we have to write what are the those. So more than one option can be correct in this question also. So I'll give you all 3 minutes. Just take your time and write the correct answer in the chat box. So D is the correct answer, that the transfer station can be direct load, where the waste from smaller containers can be transferred directly to the larger containers. B is the storage load, where the transfer station will have storage capacity to store the waste for a particular time, and from there from the storage and from there the waste can be loaded to the larger transfer vehicles. C is the combined direct load and discharge load. So in this type of transfer station, both the waste can be transferred directly from the smaller containers to the larger container vehicles, or the waste can be stored there temporarily, and then from there it can be transferred to the larger vehicles. So all the three types of transfer stations are there. So D is the correct answer. Let's move to the next question. So from question 6 to I think 11 or question number 12, it is based on numerical type questions. So the problem statement is, solid waste from a locality is to be collected on large containers, drop boxes, some of which will be used in conjunction with stationary compactors. Based on traffic studies at similar parks, it is estimated that the average time to drive from the garbage to the first location and the last container location to the garbage each day will be 20 and 15 minutes respectively. The average time required to drive between containers is 5 minutes, that is DBC is given, and one way distance to disposal site is 15.5 miles, which will be 25 kilometers, and the speed limit is also given as 55 miles per hour. And next, assume off route as 0.15, that is 15%. And constants for estimating driving time between container location for both haul and stationary container system are A is given as 0.016 hour per trip and B as 0.018 hour per mile. So we have to determine the pickup time per trip. So first let's discuss about a theory to solve this question. So, in the question, it was given to take A and B as this constants for both hall and stationary container system. But here in the question number 6, we will only solve for hall container system. That is, we will determine the pickup time per trip for the hall container system. So, okay. So for hall container system, the pickup time is expressed by this formula, where pickup time is sum of PC plus UC and DBC, where PC is the time required to pick up the loaded container, UC is the time required to keep the deposit the empty container, and DBC is the time required to drive between container location. So in the question, DBC was given, and I think PC and UC was also given. So we can find out the overall pickup time from there. So let me open the question. So this is the question. So we have to find out the pickup time. So let me write here. So in the question, DBC is given, that is the average time required to drive between the containers is 5 minutes. So DBC is given as 5 minutes. And since information about is given, so we will use this table to find out what will be PC and UC based on the what type of the truck will be used. So it is given that it is a truck with compaction. Okay, let's see how to solve this question. So in the question, the driving time between the container location was given as 5 minutes. And so if we take tilt frame, and here also compaction is being done. So with compaction, the time required to pick up the loaded container and to deposit the empty container is 0.4. So we have pickup time PHCH as PC, the time required to pick the container, UC, the time to deposit the empty container, and DBC, that is the time required to drive between the containers. And for tilt frame with compaction, the PC plus UC is given as 0.4 hour per trip, that is 0.4. So the summation of these two are given. And DBC is given as 5 minutes, so we will convert it into hour. So we will divide it by 60. And on solving, we will get 0.4833 hour per trip. So this is the pickup time. So C will be the correct answer. So sorry for the confusion at the start by like I said to assume the hoist truck, but since compaction will also be there, so we'll take it as tilt frame, and we will take the PC plus UCA as 0.4 from the table, and DBC is given, so which will be 5 minutes. So on solving, it is 0.433 hour per trip. So let's move to the next part. So we have to determine the pickup time per trip. So we have already solved this. So next we have to determine the time per trip, that is the total time which will be spent per trip. So to find out the time spent per trip, so let's see. So the time spent per trip will be, it will be sum of pickup time, at site time, and haul time. So we have already found out the pickup time, and we will see what will be the at site time and haul time. So to find out the haul time, this type of a graph is plotted, and from this table, this table is given shows the constant A and B for this for the haul time, that is R per trip, is given as H plus sorry H is equal to A plus BX. So this expression has come out after solving this hyperbola. So for a different speed limit, A and B is different. So in the question, I think speed limit was mentioned. I think the speed limit was 55 mile per hour. So based on that, we will take A and B. And next is the at site time. I think there will be a table for at site time also. Let me see. Okay. So we will take at site time as 0.133. So we have to use this table to find out the at site time. So since we have taken the tilt frame, because compaction is there in the instrument, in the vehicle, so the at site time will be 0.133 hour per trip. So we have find out how much will be S, and based on this table, that is between speed limit, we can find out what will be A and B. And since the speed limit was given as 55 mile per hour, so let me just go to the question and confirm it. So here the speed limit is given as 55 miles per hour. So based on that, we will assume A and B. So I think I have given all the values. So I'll give you all 4 minutes to solve this question and write the correct option in the chat box. So everyone, please try to solve this question. Okay, let me write the values for A and B. So I have written all the options, all the values from the tables and graphs. So please, now you just have to put these values in this formula and just calculate how much will be the time per trip. Okay, let's see. So the time per trip is the sum of pickup time plus at site time and haul time. So pickup time we has calculated as 0.483, and to find out the at site time we will use this table. In this table, at site time is given for tilt frame as 0.133 hour per trip. So we will take at site time as 0.133 hour per trip, and for and haul time, it is function of the haul distance and a plus bx. So haul distance is given in the question. Oh, sorry, I should have given you the haul distance. And a and b is we have found out from the table. A is 0.016 hour per trip and b is 0.018 hour per mile. Let's see what is x. So the one-way distance to disposal site is 15.5 miles. But haul time will be the time taken to go from the collection site to the disposal site, and to bring and to come back to the original collection site. So it will be two times this distance. So overall PHCS we have find out as 0.483. At site time is 0.133. A is given as 0.016 plus B is given as 0.018 into 2 into 15.5. So on solving this, we are getting the time per trip as 1.19 hours per trip. So B is the correct answer. I hope the solution is clear to all of you. So if any one of you have any doubt, you can ask me. Okay, let's move to the next question. So in question 8, we have to find out the number of trips that can be made per day. So this is the formula to find out the number of trips. So number of trips will be found out by this formula, where capital H, it is the length of the workday, which is generally taken as 8 hours. So for this question we will take it as 8 hour per day. And W is the off-route factor, which we will assume as 15%. It is also given in the question, so it will be 0.15. And T1 and T2 are given in the question, and which is T1 is the time to drive between dispatch station to the first container location to be served for the day, and T2 is the time to drive from the last container location to the dispatch station. And HCH is the pickup time per trip, which we have calculated in question number 7. So number of trips is calculated by this formula. So everything has been given. H is 8 hour per day. W is 15%. T1 is given as 20 minutes and T2 is given as 15 minutes. So, and THCH we have calculated in the previous question as 1.19 hour per trip. So by putting all these values, we can find out the number of trips that can be made per day. So I'll give you all 3 minutes. Just do the calculation and just write the option which you are getting, and then we will solve this question. Find out which is the correct option. So number of trips can be found out as follows. So H has been given as 8 Off route has been given as 15%. So in decimal it will be 0.15. 15 upon 100. T1 is given as 20 minute. So let's convert it to R because everything is in R per trip. So it's coming out to be 0.33 hour. And T2 is given as 15 minutes. So 15 upon 60. This is 0.25 hour. So T1 is 0.33 plus 2.5 divided by THCH. That is the time per trip, which came out to be 1.19 hour per trip in the previous question. So on solving this, we are getting 5.22 trip per day. So we will take it as 5 trips per day. So B is the correct answer. So I got one answer as B. Okay, let's move to the next question. I hope this is clear to everyone. So again from here, now I think three or four questions are there, and for all the questions, this is the common problem statement. So the problem statement is design a solid waste curb collection system to service a residential area with 800 single family dwellings. Various uh, assumptions are given. First, two manually loaded collection system are to be evaluated. That is, the first involve the use of a single loaded collection vehicle with a one-person crew, and the second involves the use of a rear loaded collection vehicle with a two-person crew. So, two collection system are given. First one, if we have single loaded collection vehicle with one-person crew, and in the second one we have the rear loaded collection vehicle with two-person crew. We have to determine the size of the collection vehicle required and compare the label requirements for each collection system. So before that, let's move to the, we will solve this question in parts. So first, so these are the data which are given. So we have all the data which we need to solve the following questions. First, we have to determine the time available for the pickup operation. So since in the question it is mentioned that it is a curve, it is a curb collection system, and curb collection system comes under stationary collection system. So to find out the time available for the pickup operation, so we will use this formula. This is the overall formula to find out the time required per day. So we have to find out the pickup time. So from this formula, we can find out TSCS, which is the time per trip. So time per from the time per trip, it is sum of the pickup time, at site time, and off route haul time. So from here there we can find out the pickup time. So first let's find out the uh, time per trip. So let's see in question what is given to us. So let me write down. So let's see what are these values given in the question statement. So we have trips per day is given as 2. T1, that is the time travel to the first pickup location, is given as 0.3 hour, and the travel time from the last pickup location is given as 0.4 hour, and we have given a off route factor as 0.15, and the nominal length of workday is given as 8 hour. So T1 is given as 0.3 hours, T2 is given as 0.4 hours, number of trip is given as 2, off route factor is given as 0.15, and the nominal length of workday is given as 8 hour. So everything is given in the question. So by putting all these, we can find out time per trip, and for the from the time per trip, we will find out the pickup time. So I'll give you all 2 minutes to find out the time per trip, and then we will discuss how to find out the pickup time. Okay, we just have to put the values, and we will get TSCS. So on solving this, We are getting TSCS as 3.05 hour per trip. So, but in the question, we have to find out the time available for pickup operation. So, we know that time per trip is the sum of pickup time plus at site time plus A plus BX. A plus BX will be the haul time. So, the pickup time will be, I think everything is given in the question. So we have been given the haul time constant and we have been given the at site time per trip. So the haul time constant is given as 0.016 hour per trip and B is given as 0.001. And we have been given the round trip haul distance H as 56 kilometer. So I think everything has been given here. So by putting all these values, we will get the pickup time. So I'll give you 3 minutes. Just put the values and write the option which you are getting in the chat box. Okay, I got one answer as B. C 2.32. 2.32 is the correct answer. So everything was given. So the time per trip is given as 3.05. Add side time is given in the question. It is given as, sorry, S was given as zero point 0.1 hour per trip. Point 1, A is given as 0.016 hour per trip. B is given as 0.011 and round trip haul distance is given as 56. So on solving this, we are getting 2.318, which is nearly 2.32 hour per trip. So the time available for pickup operation is 2.32 hour per trip. So C is the correct answer. So let's move to the next question. So we have to determine the pickup time required per pickup location for one-person crew and two-person crew. So earlier we have find out the overall pickup time. Now we have to find out the pickup time required per pickup location. So for one-person crew, we can find out from directly from the table, and for the two-person crew, we will. So for, in the question, it was given that if with the two-person crew, rear house pickup was done. So for this, we can find out the pickup time per location as follows, where TP is DBC plus KN, CN plus K2 PRH, where PRH is the rear of house pickup location. So we will see how much is that given. And let's see what is DBC given and what is CF, CN and K1. So DBC is the average time spent driving between the container locations. K1 is the constant related to the pickup time per container. And CN is the average number of containers at each pickup location. So let's see. So the constant is given as K1 is given as 0.18 and K2 is given as 0.22. And number of containers. So the container per service, that is per pickup location, is given as two 12-liter containers plus 1.5 cardboard containers. So 2 plus 1.5, it is 3.5 containers per location. And DBC, that is the time to travel between the between container location, it is given as 0.72. So in the question, what is given? DBC is given. It is given as 0.72. K1 is given as 0.18. Average number of containers per pickup location is given as 3.5. And in the question, it was written that we have to design a solid waste curb collection system. So there is no real So there is no rear of house pickup location, that is 0. So K2 is 0.22, PRH is 0. So we can find out the for 2-person crew how much of time per pickup location is required. So it is DBC plus K1CN plus K2PRH. So this is for 2-person crew. And for 1-person crew, we can find out from the table. So just read that from the table and write the correct option in the chat box by solving the overall question, and then we will see which is the correct one. Yes, C is the correct answer. So for 1-person crew, we can find out the pickup time per pickup location by using this table. So we can see that average number of containers or boxes per pickup location, it was given as 3.5. So we will use the second row, that is for 3 or more or unlimited service. So the pickup time will be 0.92. So it will be 0.92 collector minute per location. And for the 2-person crew, we will find by using this formula. So already DBC is given as 0.72. K1 is given as 0.18, average number of containers is 3.5, and K2 is 0.22, but there is no pickup from the rear house, so PRH is 0. So on solving this, we are getting as 1.35. So it will be 1.35 collector minute per location. So 0.92 and 1.35. So we are getting C as the correct answer. So let's move to the next part of this question. So question 11 is determine the number of pickup locations from which the waste can be collected for one-person crew and two-person crew. So we have to find out the number of pickup location. So for manually loaded collection vehicle, we can find out the number of pickup location by using this formula, which is 60 PSCS N by TP, where PSCS is the pickup time per trip, which we have find out in the first question. Next is N. N is the number of collectors or laborers we have. So we have one person crew and two-person crew. So N will be 1 for the one-person crew, and for two-person crew it will be 2. And TP is the pickup time per pickup location. We have calculated it in the previous question. So number of trips is 60 PSCS N by TP. So we'll find out for one-person crew, and we'll find for two-person crew. So what we have found is we have found out PSCS as 2.32 hours per trip, and we have found out TP for one person crew as 0.92 collector minute per location. And for two-person crew, TP is 1.35 collector minute per location. So this by directly putting these values in this formula, we can find out the number of pickup location for one-person crew and two-person crew. So please solve this question and write the correct option in the chat box, and then we will see which one is the correct. So let's see how to solve this question. So, I got one answer is C. Yes, C is the correct answer. So for one person crew, TP has been given. Number of pickup location will be 60 into PSCS is given as 2.32. N will be 1 because it is one person crew. Divided by TP. So sorry, TP is given as 0.92. So on solving this, we are getting the number of pickup locations will be 151.3. So we'll take it as 151. And for 2-person crew, number of pickup location will be 60 into, again, pickup time per trip is 2.32, number of crew is 2, divided by time served per location, it is 1.35. So on solving this, we are getting 206.22. So it will be nearly approximate it is to 206. So 151 for 1-person crew and 206 pickup location for 2 crew. So 151 and 206, that is C is the correct answer. Okay, I hope this question is clear. Let's move to I think the last question for today's problem solving session. So the question is, determine the size of collection vehicle required for 1-person crew and 2-person crew. So we have to find out the volume of collection vehicle required. So to determine the volume, first we have to find out how much is the waste generation in that locality. So let's go to the question. So we have been given waste generation rate per capita, that is per person, how much waste is generated per day. We have been given the collection frequency, which is once per day per week. So collection is done once in a week. And we have been given how much person is there per pickup location, that is average number of residents per service or per location is 3.5. And we have also given the density of the solid waste, which is 119 kg per meter cube. So we can find out the volume of the waste which is generated. So let's see. So we will find out how much of the volume is waste is generated, and we will find out for the entire week because collection is done once a week. So volume of waste generated per pickup location per week will be waste generation rate it will be in how much kg of waste is generated per capita or per person per day into average number of residents served per pickup location. So it will be in person served per pickup location into for how many of days the waste will be collected divided by density of the waste. So we have been given the waste generation rate as 1.13 kg per capita per day. We have been given the average number of residents to be served per location as 3.5 person per pickup location. And collection frequency is once every week. So we will the waste will be collected in the curb system for 7 days. So it will be 7 days divided by density of the waste, which is given as 119 kg per meter cube. So on solving these, we will get how much of the waste is generated per pickup location for the entire week. So it is coming out to be 0.233 meter cube per location, per pickup location. And we have to find out the size of the collection vehicle which will be required for 1-person crew and 2-person crew. So the size of collection vehicle will depend upon how much waste is generated and how much number of trips will be done per day in 1-person crew and 2-person crew, and if there is some compaction which will be there in the collection vehicle, so we have to take the compaction ratio also. Let's first go to the question and see if compaction ratio is given. So yes, the collection vehicle compaction ratio is given as 0.25. So compaction ratio is given as 0.25. So okay, let me write the formula here only. So the volume of collection vehicle will be how much waste is generated per pickup location into number of pickup location that will be served divided by what is the compaction ratio. So this formula will be used for both 1-person crew and 2-person crew. So in the previous question, number of pickup location NP for 1-person crew, I think it was 155, and for 2-person crew it was 206. Yes, sorry, it was not 155, it was 151. 151 location per trip for 1-person crew and 206 location per trip for the 2-person crew. So by putting this in the formula, we will get how much should be the volume of collection vehicle. So please do the calculation and write the option which you are getting in the chat box. So C is the correct answer. So for one person crew, the volume of the collection vehicle will be VP NP by R. VP is the volume of the waste which is generated per pickup location, which we have calculated as 0.233. Number of pickup location per trip was 151 and compaction ratio is given as 2.5. So on solving this, we are getting 14.0732. So nearly 14 meter cube. For two-person crew, volume of collection will be calculated using the same formula. We have the volume of waste generation generated, this much of meter cube per location. Number of location is 206. And we have been given compaction ratio is 2.5. So the volume of will be 19.199 meter cube per trip. So if we will approximate it, it will be 19 meter cube per trip. So the size of collection vehicle for one person crew is coming out to be 14 meter cube, and for two-person crew it is coming out to be 19 meter cube. 14 and 19. So C is the correct answer. So this was the last question for today's problem solving session. I hope all the questions are clear to everyone. If any one of you have any doubt, then we will discuss. Otherwise, we will end the today's session and we will meet on next Saturday from 6 to 8 p.m.
Ma'am, for final exam, do we need to memorize the formula, or are they given? Will they be given?
So formulas you need to remember, but the values which we are taking from the table. So these table and graphs will be given for, but for formulas like for pickup location, number of trips, all these you have to remember.
Okay, thank you.
Okay. So if there is no doubt, so we can end the session here. So everyone, thank you so much for joining. Have a nice day. You can leave the meeting.
Thank you.